So today we'll be moving on physics. So now today we'll be checking on measurement of heat. So checking on measurement of heat, the method of mixture, when mixing cold water and hot water together, they'll be changing in temperature. Now before entering into this, let us move into some question like changing in temperature, hotness of a something, hotness of a substance. So let's check the question. Looking at this question, what is the quantity of heat that will be given out if a bar of brass of mass 350 gram is cooled from 95 degrees Celsius to 20 degrees Celsius? So given the specific heat capacity of brass, something is heat and it is cooled from what? At this temperature from 95 degrees Celsius to what? 20 degrees Celsius. So looking at this formula, we all know that quantity of heat passed is equals to the mass times the specific capacity. This is the sign for specific, and this is the change in the temperature. Now, something is being cooled. The brass is being cooled from 95 degrees Celsius to what? To 20 degrees Celsius. So the temperature changes must be change. Okay, this is the formula to solve the question. We all know quantity of electricity passed. So quantity of heat, quantity of heat. As I said earlier on, this is the quantity of heat. So quantity of heat, in the question we were told to look for the quantity of heat, and the formula for quantity of heat is mass times specific heat capacity times change in temperature. So the changing in temperature of the mass, the brass is very hot, at what? 95 degrees Celsius, and now cooled. So you guys must notice that there is changing in temperature. What was the changing in temperature? When something is at 95 degrees Celsius hot and get to 20 degrees Celsius, the things more the thing had lost some heat. So the heat lost, that's the changing in temperature. So we subtracted 20 from 95, so that is the changing in temperature. We get 75, so the formula says mass. This is the mass. So the mass is in gram here, but we want to turn it to kilogram, so we divide it by 1000 times the specific capacity times the changing in temperature. So when we multiply all this, so our answer will be, so you can this cancel this cancel this, so when we multiply everything, so we arrive at 9975 joules. Final answer. Looking at the looking at the second question now, 500 gram of water is heated so that its temperature rises from 30 degrees Celsius to 72 degrees Celsius in 7 minutes. Calculate the heat supplied per minute. So the question is asking us to calculate the heat supplied per minute. So the specific capacity of water is given. So let's solve that. The heat supply per minute, so that's the question says. The question says we should look for the heat supplied per minute. So I said it earlier on that quantity of heat equals to what? Mass times specific capacity times change in temperature. So the question, this is the mass given in gram, then the temperature, then the final temperature, then this is the changing in temperature. That is, what was the change when water is being boiled from 30 degrees Celsius to 70 degrees Celsius. So you should know that the water is very hot at this point of the time, but there is a changing in temperature. The thing rises, the temperature rises from 30 degrees Celsius to 70 degrees Celsius. So the changing in temperature is 40 degrees Celsius. So we need it in our formula here. So looking for the quantity, the question says the temperature rises from 30 degrees Celsius to 72 degrees, as we said earlier on, in 7 minutes. So in 7 minutes, the temperature rises from 30 degrees Celsius to 70 degrees Celsius. And the question asks us to calculate the quantity of heat supply per minute. So from this point to this point, at this time. So looking, the quantity of heat equals to the mass. So we need to convert this to kilogram. So 500 divided by 1000 multiplied by the specific capacity. So we were given that 4200 multiplied by the changing in temperature. So when we cut this, and this cancel this cancel this. So when we multiply all together, the quantity of heat will be equals to. So I'm so sorry, you guys. There was mistake in the question. So when you look at it critically, the temperature was is 72 degrees Celsius. 72 degrees Celsius. So about degrees Celsius. So you just need to change this to so so 72 minus 30. So that one will give us 42. So degrees Celsius. So at this point, the cutting, let's recut. So this is 500, 4,200, 40, 40, and this is 1,000. So when we cut, you can just cut this, cancel this 2 there, cancel this. So what remains? So when you multiply everything together, the answer will be 8,200 joules. So the question now says, in 7 minutes the temperature changes from this to this, but the question asks us to look for the heat supply per minute. That is, you now say 7 minutes this heat was supplied. That's 2,000 joules was supplied. You now say the one they asked us to look for, x minute. What heat was supplied, we don't know, so we want to look for this. 1 minute, they say per minute, so per minute means 1 minute. So x joules, s heat was supplied, so we don't know. You can just cancel the joules, since you know that what you are looking for is in what must be in joules, so you should know that you are solving, you want to look for in joules. So when you cross multiply, this is, so x times 7x equals to 1 times 88 to give us 88200. So divide both sides by 7. So because it's beside coefficient of x is 7, so 7x over 7 equals to 88200 over 7. So 7 cancel 7, so s equals to 12600 joules. Final answer per. So the heat supplied per minute is 12600 joules. Final answer. Looking at the method of mixture form, for instance, hot water and cold water, maybe when mixed together, you will notice something, that there will be change in temperature of the hot water. Maybe the hot water is at 100 degrees Celsius when mixed with cold water at 0 degrees Celsius. So you notice that the hot water, it won't be hot as it is before, as it was before. The water will never be hot as it was, because it has already loses some heat into the cold water. So let us go into that kind of question. Hot water mixing with cold water, that's called mixture method, mixture form. So let's check the question. So before looking at the question, I want you guys to know this. Changing in temperature when hot water is being mixed with cold water, you will notice, maybe for instance, maybe the water is at 100 degrees Celsius. Okay, let's check the question. So we can explain better. So looking at this question, calculate the final or equilibrium temperature of the mixture of 250 grams of water at 65 degrees Celsius is added to 150 grams of cold water. This cold water, this is hot water at 65 degrees Celsius, is added to 150 grams of cold water at 5 degrees Celsius. So neglect heat absorbed by the surroundings. When they are mixed, so you will know that there will be heat loss to the surroundings. So the question says we should neglect it. So let us solve the question. Go. Now, the formula to calculate method of mixture, you say heat gained by cold water equals to heat lost by hot water. I said it earlier on, the cold water gains it to itself and the hot water loses it to the cold water, because the one is initially the hot water is hot when mixed. When it is now mixed, the temperature, the rate it was before, to reduce, there will be decrease in the temperature, while there will be increase in the temperature. So for us to calculate the hot water, this is changing in temperature for hot water. That will be when it is hot, subtracted minus. Now when hot water and cold water are mixed together, you will notice that when the hot water was at 100 degrees Celsius before, when now mixed with cold water, you will notice that the water will now get to some temperature. For instance, maybe a man want to bathe with want to bath with water of 30 degrees Celsius, and now place the water on fire. So and the water was at is at 100 degrees Celsius. So when and we said it that the man want to bath with the water at what, 30 degrees Celsius. So you notice that the man will surely mix the water with cold, the hot water I mean, with cold water in order to reduce the temperature. So the temperature the water was that by which the man wants to bath with it, so that is the final steady temperature. So now in the question, we're told to look for the final steady temperature. So how are we going to calculate the final steady temperature? So this is the final steady temperature. Something at maybe okay, let's check the question. So the formula to calculate it is heat gained by cold water equals to heat lost by hot water. The hot water loses it into the cold water, and the cold water gains the heat. So okay, now the cold water, now this is the formula. We said it earlier on, quantity of heat, so mass times specific capacity times changing in temperature. So let us consider the for cold water now. We said heat gained by cold water equals to heat gained by heat lost by hot water. So this is the formula, mc theta mc change in theta. So what's the mass for cold water? The mass is 150. Note, mind you will convert it to kilograms, so over 1000 multiplied by what's the specific heat capacity. So the specific capacity, because we are dealing with water, we had 1000, I mean, I'm so sorry for that. So we are dealing with water, both are water, just cold water and hot water, but they are water, the same specific heat capacity, times 4200 times what's the changing in temperature. That is, now to look for the changing in temperature for cold water, eh, it gains it to itself. So the temperature must be at, the question says the water is at 50 degrees Celsius, and what's the final steady temperature when the water are both mixed together? So the question asks us to look for that, the final temperature, the steady temperature, that is the final temperature when hot water at 65 degrees Celsius, hot water at 65 degrees Celsius is mixed with cold water at 5 degrees Celsius. So you guys must know that there will be at least the hot water will gain some heat. So the heat gain, this is the formula for it, for hot and cold water gaining it some temperature. So final steady temperature minus the coldness of water, that is theta. This theta is the final steady temperature minus the this minus 5. How did we able to get that? Just to look for the temperature. So you say theta minus 5 equals to, so what's the heat loss by the hotness of water when the hot water is added to the cold water? I said it that it will lose heat, that is this 65 degrees Celsius will never be 65 degrees Celsius again. So there will be reduction in the temperature. The temperature will reduce when adding cold water to hot water. You will notice there will be some changes. So the changes for hot water will be, okay, let's consider the mass first, also the same thing. The mass is 250 multiplied by the specific heat capacity, the same thing, times. So how are we going to calculate it? You will notice that from 65 to what, to the final temperature. This is the formula for it for hot water, from hotness of the water 65 to the final steady temperature. But for coldness, so since it is cold already, it's not hot, but at this point it's still hot, so that is why we subtracted the coldness from the hotter one, because this is hot, just a little while hot, the final steady temperature, but at this point it's not as hot, it is not hot, but at this point it is hot, so we subtracted it. So for hotness of water, hotness minus the final steady temperature, because this is not as hot as this, so it will be 65 minus theta. So the question asks us to look for the final steady temperature. So you guys can just write it out in short form. I want to write time. So mind you, this is over 1000, the 250 gram convert to kilogram. So this cancel this, these two cancel these two, also this, so by not cancel it, you can also leave it. I want to do something there, leave it 150. So this cancel this, you can still say divide both side by 4200, since they are the same. So when you multiply 150 multiply by this, okay, let's cancel this. So when you divide this, it will give you 150 divided by 1000. So 150 divided by 1000 will be 150 divided by 1000. So that one will give you 0.15 multiplied by theta minus 5. So the other side, 250 divided by 1000 also. 250 divided by 1000 will give you 0.25 into bracket 65 minus theta. So when you multiply this, you will get 0.15, that's 0.15 theta minus, so this multiplied by this also, you will get 0 minus 0.75, so equals to the other side. When you multiply this, it will give you 16.25 minus 0.25. So you collect like terms. So when you collect like terms, bring in the theta, no, sorry, theta is here, this times this, you give it this. So bringing this to this side, now is 0.15 theta, this is minus turns to plus when coming inside. 0.25 theta equals to 16.25. So this doesn't have theta, so you bring it to this side to come and meet 16.25, so turning to plus 0.75. So when we add this together, and we arrive at 0.4 theta, and this, when we add also this together, we get 17.0. So you say divide both side by 0.4. what beside theta? That's 0.4 by 0.4. So 0.4 cancel 0.4. What's left? Theta. So theta equals to 42.5 degrees Celsius. So this is the final steady temperature at which the water stayed, when both when the water are mixed together. So it gets to a final steady temperature at which the man can bath with it. I cited an example of a man wanted to take his bath with water at 30 degrees Celsius. So at this point of a time, and when both are mixed together, the final steady temperature I mean, is 42.5 degrees Celsius. So I hope you guys enjoyed today's lesson, and thanks for we thank God. All glory we give it unto God. But today I want you guys to practice this question, and when you if you have any question on this, I want you guys to click on the subscription button below. So clicking on the subscription button doesn't mean anything, so just to notify you whenever my video are out. So thank you and God bless you.